Hi everyone, welcome back. Today we're doing find words that can be formed by characters. And we're given an array of strings words and a string characters. A string is good if it can be formed by characters from this string, and each character can only be used once. And we have to return the sum of length of all good strings in words. So for example, if words is a list of words like this, and we have the characters like this, then in this case, we can form cat from chars. C-A-T is present in chars. So in this case, cat is valid. For BT, chars doesn't have B, so we can't form BT. For hat, we have H-A-T in chars, so this is valid. But for tree, there's no R in chars, so tree is not valid. In summary, the words that we can form using characters in chars is cat and hat. So this gives us a total length of 6. For the second example, we have words equals to hello world Leetcode, and chars contains well done honey. So in this case, we can form hello. H-E-L-L-O is present here, so hello is valid. World, similarly we have W-O-R-L-D, so world is valid. For Leetcode, we have L-E-E, but we do not have T, so Leetcode is not valid. In summary, for the two words that are valid, the sum of all characters is 10, so we output 10. So for every word that exists in the input, we have 1 to 1000 words here. And for every single word inside this list and chars, they range from length 1 to length 100. And finally, all words in words and chars consist of lowercase English letters. So we don't have to worry about uppercase or lowercase in this case. So one strategy that we can use to solve this is by keeping track of all characters and their counts in chars using a dictionary. So let's call this char counts, and this can be a dictionary of string to integer. And we will be able to populate the chars counts in chars by updating this like this. So if the character doesn't exist in a dictionary, then just default it to 0 for this expression and add 1 on top to that and just update it inside this dictionary. And once we have these char counts, what we can do is we can create a copy of this dictionary for every single word. And for every single word along with this copy of this dictionary, we can check if every single character in this word is present inside that copy of the dictionary. And if it is, then in this case we would decrement the count in the dictionary and continue. And by any chance, if there's not enough characters, then we will use a boolean to flag it as false, like for example is valid. And after this check, if this word is still valid, then we will add that to a final integer that keeps tracks of all counts of characters. So we can define a count char. This will be equal to 0. This integer over here will keep track of the total count of valid words. So once we're done, we can iterate all words in words for word in words. We will make a copy of char counts for this given word, so that if we update this dictionary, the original dictionary of counts stays the same for the next word. So char count, we can do word char counts. This will be a dictionary of string to integer. And what we can do is we can make a deep copy of this dictionary. By the way, you could have used a shallow copy, because a shallow copy copies the values of the values in the dictionary by reference. And because each of the values are numbers, is totally fine. But if you wanted to use a list, then please remember to use a deep copy by any chance if you need to have an actual copy of the values in the dictionary. But for all purposes, for showing what a deep copy is, I'll be doing import copy, and I will show you how you use a deep copy in a minute. So for now, we will set this to copy.deepcopy, and we will pass in the char counts. And this will allow us to make a deep copy of this. And every single value in char counts is going to be a copy by value rather than a copy by reference. If you'd like to know more about that, I will link a simple Stack Overflow thread in the description below, and you can give it a check. So once you have these counts, we can start iterating all characters in this current word. So if word char counts dot get char is more than equals to 1, then in this case, for this character, it is a valid character. So what we will just do is decrement this current character by 1. Else, in this case, if this character cannot be formed by the characters in chars, it might be because we run out of characters or we do not have that character at all. So in this case, we would define a simple boolean. Let's call this valid word. This boolean would just indicate if the word is valid or not. And if it is not valid, in this case, we'll set this to false and we would break this linear scan over here. Because we have just proven that this word is valid, there's no need for us to continue the check. And in this case, if the word is still valid after this linear scan across words, then what we will do is we will increment the count chars by the length of the current word. And that's pretty much it for the implementation over here. So now let's try using this example over here to check if this expression is right. So first, we will initialize character counts to an empty dictionary. And the next step would be to set this count chars to 0. We will start to iterate all characters in chars. So char is now currently equals to A. So we are currently iterating this chars and we are at the first character right now. So now we update char inside our character count. A will be 1. Let's move on to the next item, T. T will be 1. And we encounter A again. So this is 2. We encounter C. Let's update C into this character count. And finally H. So H would have a count of 1 in char counts. So now we're done with lines 15 to line 16 and we have successfully populated the counts of all characters in chars in a dictionary. And now we can use this dictionary to check if every single word is valid. So let's set word to be equals to cat, the first word in words over here. And we would just set this word char counts to be a copy, a deep copy of char counts. So once again, it's totally fine for you to use a shallow copy over here. This could have been just char counts.copy, and this would be returning a shallow copy of char counts. So this would be an object by itself, but the values here are really pointing to the same reference values as in char counts. So in this case, it would still work because in this case, these are all values, so that's okay. But if this was a list, please be careful to use a deep copy. If you want your copy to have its own list, and you wouldn't want to edit this list and end up editing the original list in char counts. So anyway, I digress. Let's continue. So over here, valid word is equals to true. And let's start iterating the character for this current cat over here. So in this case, C is 1. So this is true. And we will decrement this by decrement C by 1. And we move on to A. Now A exists. A has at least a count of 1. So we will decrement this. And this is true. And finally, we're at the final character in cat, T. And because T exists, we will decrement it. At this point, we're done with line 29 to line 34, and valid word is still true, so we increment count character by 3. So now we have 3 over here. Now let's move on. Now we have BT. We will re-update the word char counts. The word is now pointing to BT. Valid word is now set to true, and the char is now pointing at the first character in word. So in this case, B doesn't exist here, so this will be false. And we will set valid word to false. So valid word will be set to false, and we break the loop over here. And now we hit line 36. And since valid word is false, this will not be executed. And we will move on to the third word over here. So now this is pointing to head, and we are going to repopulate word character counts, reinitialize that as a deep copy. And now the valid word will be reset to true, and we will start checking the character over here. So head, the first character in head is H. H in this case exists, so we will decrement this, and this will be true. Let's go to A. A exists in word character count, so this would be 1, and this will be true. And finally, the final character is T. T exists, so we will decrement that. This will still be true, and we're done with the linear scan across line 29 to line 34. So valid word is still true, so we will increment count characters by another 3, giving us 6, since the length of word is 3. So we are at the final word over here. We will reinitialize the character counts on line 21 again. Reset valid word to true, and now we will start iterating all characters in tree once again to check if this is valid. So character is T. In this case, T exists, so we have 0. This is true, and we decrement the count of T in word character count. Now we point at R. Unfortunately, in this case, R doesn't exist in word character count, so this is false, and we break, and valid word will be set to false. And since valid word is set to false, we do no more increments. And now we get the answer count char equals to 6, and this corresponds with the output. So it looks like this approach works. Let's code it out. So we got most of the implementation right. We will just repeat that so that we understand this. So the first thing is to define character counts. This will be a dictionary of string to integers, and this will keep track of all characters in chars. So now we do for char in chars. We will update the character counts with the corresponding counts for each character. So char counts.get char 0 plus 1. So at this step on line 43, we have updated the dictionary of counts, and we are ready to use that to check if every single word is a valid word. So we will also define count chars. This will be equal to 0, and this will be assigned to the count of characters for all valid words. So for word in words, we will start to define a copy. Let's call this word char counts. This will be a dictionary of string to integers, and we'll be making a deep copy, copy.deepcopy of char counts, so that we do not edit the original char counts as we keep track of what characters we have left. So now that we have word char counts, we can define valid word boolean. This will be equals to true for now, and this will indicate if the word that we are iterating is valid. And for char in word, we start to check if this word char counts is at least more than equals to 1. And if this character exists in chars, then we will update this count by decrementing it. Else, if we do not have the word at the moment, then what we will do is we will set valid word to false, and we will break this. And at the end of this linear scan across all characters in word, we will check if the word is still valid. And if it is valid, then we will update count chars by incrementing with the length of word. So that's pretty much it for this implementation. Let's remove all of this and just trace this again. So char counts equals to dictionary. We set count chars to 0. Thank goodness we checked it. I forgot to return the final answer on line 21. But we define count chars, and we proceed to add all characters into this dictionary to keep track of the count of every character. We would then start to iterate across all word in words. We will make a copy of the original char counts, and we will use this word char count, a temporary dictionary, to check if we still have enough characters for each character in the current word. And if it is valid, then we will increment the count chars by the length of the word. Looks like everything is fine. Let's run this against some test cases. This passes. Let's submit this. And there we go. So in this case, the time complexity, if we let C, let's see N be the length of words and C be the length of chars. In this case, we iterate all characters in chars. So in this case, it's OC to update all characters into character counts. And we iterate through all words here as well. For every single word that we iterate, we do a deep copy of char count. So this is going to take OC time because we're making a copy of the dictionary over here. And if the this is going to be very fast. We're iterating through all characters again for every single word. So this is OC as well. And at this point, that's pretty much it. So in summary, the time complexity is OC plus O and 2C for every single word. So if we remove the coefficients and we remove the lower base, the time complexity is O and C. For the space complexity, let's remove all of the time complexity markings again. And let's check. So on line 18, we proceed to update character counts with all characters and their corresponding counts. So in the worst case scenario, if character count contains only unique characters, then you will have as many keys as many characters in char. So in this case, it's going to be OC in the worst case. And over here, we make another copy of this same dictionary here again. So this is going to take additional memory. Fortunately, this will be overwritten every time we move to the next word. So it's going to take OC throughout the whole iteration over here. For the rest of the variables, these are just standard single memory used for these integers and booleans. So those are going to take O1. So in summary, we will use O2C. Removing the bases, it will just be, coefficients. The space complexity will just be OC. So that's pretty much it for this demonstration. I hope this was useful. If you like this demonstration, please give us a like and subscribe, and we will see you in the next video.